Hello, everyone.
Right. Okay, good. I mean, worst case scenario, everybody can just fill up the first couple of rows and we can speak without a microphone. All right.
Yeah, I think it's working.
Yeah.
Cool.
Yeah, good. Cool. So, hey, everyone. I'm Badri, and
I'm Akshay.
And we work on snapci.com, which is we work at ThoughtWorks on the product SnapCI, and it is a hosted continuous delivery tool. It's built ground up to support continuous delivery practices with a full-on deployment pipeline baked in. And what we're going to be talking today is our experience over the last couple of years working on the software and building it, and our experiences getting continuous delivery going on a software that is supposed to enable other people do continuous delivery. It's a bit meta, but we're not going to be talking very much about the software at all, more about our experiences, so hopefully it doesn't get too confusing. So, Akshay, you want to... I'm the product manager, so I used to be a developer, don't do very much coding anymore, and
I am a developer on the team.
Hands-on, he does all the important stuff. I like to think I make the important decisions. He actually does the things that matter. Oh, wow, that's very quick. Okay. All right, first, we want to start out with a couple of definitions. Just the definition of continuous delivery itself. The interesting thing about the book Continuous Delivery, if you guys notice, is that there is no definition for what continuous delivery is in that book. So I think Martin Fowler had to coax Jez into giving a formal definition of it on his website, and this was what Jez came up with. He said, the essence of my philosophy to software delivery is to build software so that it is in a state where it could be put into production, and we call this continuous delivery because we are continuously running a deployment pipeline that tests if the software is in a state to be delivered. Key part of this is building software in a way such that it is in a state where it could be put into production. That's the key part of it. Why does it keep advancing? Keeps killing the punchline. All right. So, how many people have seen the Puppet Labs State of DevOps report from 2014? Right, great. Actually, the State of DevOps survey for 2015 is out right now. So if you haven't already filled in the details on that, it would be really great if you folks could go in and put in the details of how you see the world evolving around you. It'll make the 2015 report that much richer. But from the 2014 report, this was one of the key things that came out of it, which was that high-performing organizations are still deploying code about 30 times more frequently with 50% fewer failures. And the interesting part of it is that there is a correlation between those two than lower-performing counterparts. You'd think that deploying code that much more frequently would result in catastrophic failures where every deployment does something new and crazy, except these companies, the ones that are performing really well, seem to be doing it much more frequently and much more reliably, which, and the minute you hear that, this is most people's reaction. Of course, I gave the punchline away by putting the surprise cat a little bit early, but that's most people's reaction. How can I get in on that action? How can I deploy more frequently? How can I have lesser bugs? I mean, it seems like unicorns and rainbows when it's actually portrayed that way. The long, hard road to achieving that is actually sometimes left out. So, the essence of continuous delivery is being able to do frequent, reliable releases of high-quality, valuable software. Let's keep that minimal definition in mind. It's going to be helpful. So, the point, though, is where do we get started? The world of tools around this practice it's exploding. There are new tools every day. Just when we thought we'd learned the difference between Puppet Manifests and Chef and decided which side we wanted to go, there's now SaltStack and Ansible, and we don't know if we want Ansible with tar or without. And so the tools are evolving around us really quickly, and we don't really know where to get started. Should I start with IaaS providers or PaaS providers, or should I start with a simple framework that can be a simple application that can be built as a monolith and deployed as one component, or should I start with microservices? Should I roll my own monitoring, or should I use monitoring as a service? All these decisions are available to us, and this causes a lot of analysis paralysis in knowing exactly where to start. Once the end state is reached, it becomes quite easy to understand where you should have started, but unfortunately by then, things are a little bit set in stone and you can't really undo some of the decisions you've made. So with that in mind, where did Snap start? We started back in 2012, and for about, what would you say, was it about 6 months into the project?
Yeah.
Yeah, into 6 months in since the day we first started writing code. This is kind of what Snap itself looked like. We had about 9 components, microservices before that term was actually out. We had a message queue because everybody knows that if you're passing messages from one system to another system, you need a message queue because you can't do it without that, and we wanted this to be really, really fast. Keep in mind at this point we had no customers. In other words, the rate at which messages were flowing through the system was glacial, but we still had a message queue. We had Chef Server for infrastructure provisioning. We had both relational and NoSQL databases because that was the cool thing to do at that point. We had extensive Nagios monitoring. We had so much Nagios monitoring, everything that could possibly be monitored was being monitored and tracked. And we had a completely automated infrastructure creation, provisioning scripts, everything from the dev environment to every single environment that we were running our production servers on. All of that was completely automated. And we had complete build and deployment pipelines for each of these components. And with all of this in place, you would have thought we had it nailed, right? I mean, we've gotten all the bits that you need. Microservices, we've got all the monitoring we need, we've got all the build pipelines. I mean, it's a bit of a setup and it seems a bit contrived, but that was about as close as we were to hitting the mark. Pretty much every single thing that we did, well, why don't we just look at the consequences? So we, as I said, we are a hosted CD tool. When people log into Snap, they expect to be able to set up their build, get a build result, set up a deployment pipeline that takes their code all the way from GitHub changes through to production. The likelihood that a user would be able to sign in and set their build up in Snap, a working build up in Snap, was about 50%. 1 in 2 users would sign in, and at this point it just meant we were doing usability testing, right? There were no real users. Half the times when I did a usability testing, the system just wouldn't work. People wouldn't be able to set up their build. The second rule of continuous delivery, every change in your version control system must trigger a build. Snap would trigger builds about half the time. So half the users wouldn't even get a build set up, half those builds would not trigger. Likelihood that somebody on this dev team actually knew why the builds weren't triggering. The likelihood of me asking the question why and 4 SSH sessions immediately starting up on a dev's box to get into all those machines, tunnel into all those machines and find out which process was breaking in what way, roughly around 100%. Likelihood that the infrastructure was busted, around 50%. Frequency of production upgrades, about twice a month, which I understand might be a lot more frequent than most people do it, but in my opinion, that's horrendously slow. Yeah. And the consequence of doing these upgrades was that the entire site was unavailable. We'd do an upgrade, we'd take a downtime, and for 3 hours the site would be unavailable. And this was all for this wonderful bit of a 50% working build, or 50% working system. So, I guess, more importantly, when things failed, not only did the dev team not know what was going on, even the users would not know what was going on. You'd just get a blank screen. So talk about providing valuable feedback to users and giving them an opportunity to relay that back to the development team. Let's say that was next to not available. So yeah, in the frequent, reliable releases of high-quality, valuable software, we can pretty much scratch out frequent, reliable, high-quality, or valuable. And really all we are left with is, I wish this would stop doing 2 at a time, is releases of software. I mean, seriously, if that's the bar we are aiming for, we should just all go home. So that's what we were doing, though. So in terms of grades that I'd give us, it is a grand F. And clearly, we needed to work past that point. And we spent most of, around December 2012, we decided that what we were building and the way we were building it was completely broken. We needed to re-examine our core values, why we had made the decisions that we had made. Just to give some amount of context, and without having this sound defensive, we had actually taken a lot of what we got, the chef scripts, the chef recipes, the Nagios monitoring, all of that had come from another system that we had already built internally. So we had all of that available to us. So we were tempted. We were like, oh, hey, we've got all that stuff. Why don't we start using it right away. We know we're going to need monitoring. We might as well put all the Nagios monitoring we had written for the other system. We know we're going to need chef recipes for the exact same things that we had over there. Why don't we just copy all those chef recipes over? And so this is less about justifying why we were in the situation we were in, but just as a warning to say, even now out there, Ops code has got recipes for just about installing every single thing you could possibly want. Don't fall prey to the temptation of copying those into your code base and thinking that you need them because they're there. That's the temptation that we fell into. And so if this journey is about anything, it's about the mistakes we made and being open about them so that others don't have to make the same ones. So with that in mind, don't feel the necessity to start taking free code that might be available for doing all these things and get yourself into a bind like we did. So clearly we worked our way out of there. It required quite a bit of re-architecting, removing a lot of components, changing them, and Akshay will talk you through those.
Yeah.
This is just flaky as hell. I'm not going to give it to you.
Yeah. So like Badri was saying, that we had everything. We had microservices, we had automation, and we had a lot of tooling around, but we still weren't able to deliver. So to make the changes, what we decided is that let's start with the thing that was causing the most problem. And one of the things was that we were using a messaging system called RabbitMQ, and it was a complex multi-process system which was very highly scalable. It would deliver everything for you. It would scale very well. And so we decided to use that initially. And what we did is that Snap allows users to set up their own builds. And what we did is that for every build that the user went and set up, we used to create a special queue just for that build. So whenever we used to get any build request from GitHub, you do a git push, it would be queued inside that particular queue just meant for that user. So we put this in, and it was like, okay, this should work fine. We have one queue. So every project got its own queue. What can go wrong with that? But the thing that we made a mistake was that we chose a client, a DSL, for that tool, which was very naive. So it was very immature in its state. And because of that, what we saw is that we started to use that DSL, and we saw that our messages were actually being lost. So we get build requests from GitHub, you do a git push, but suddenly it's not there in Snap. Where did it go? So we decided that, okay, there must be some problem. Let's just try to redeliver. Like we had that message sitting somewhere. It's just not getting to the build system. So we added another queue on top of it, which would basically ensure that we would get acknowledgements from the build machine that, yes, I have received this build and I've started building it. But it again increased the complexity, and we saw that it was just not working for us. So what we decided is that we didn't have a lot of build activity on our system. Did we really need to go for a solution that was multi-process, well to scale, etc.? No, not really. We could do much simpler solutions. So what we tried to move to is that we found something called as a delayed job, which is a gem provided in Ruby. And what it does is that it's basically a background job processor based on databases. So it basically uses a database table as a queue. And what you can do is that you can put in your jobs, and the delayed job will basically make sure that it hands it over to the right consumer. So when we moved to the system, it was very simple. It was one single queue for the entire system. So there was no more per queue. Every project didn't have its own queue. It was just one single queue for all the projects set up on Snap. So it was really simple to manage. It was single process. So we didn't have to deal with a complex system. We didn't have to deal with RabbitMQ. It was a simple gem, which is really easy to manage. And because of that, we basically moved to a technologically inferior solution, but it was way simpler to manage, and it was way simpler to handle for the team at that time. So next thing, like Badri mentioned, that we were using Nagios. So the way we were using Nagios was that if you see in a lot of rings, there is one ring to rule all of them. So similarly, we had Nagios to rule all our monitoring. So right from our process, all our CPU monitors, our application monitors, everything was basically managed by Nagios. And Nagios provides a lot of plugins to basically monitor your application, your server, And we decided that, what the hell, why not use all of them? So we put in all the monitors and we were getting a lot of metrics. We were like, yeah, this is good. We are getting a lot of metrics back. And since we were getting a bunch of metrics, we didn't really know how to configure the right alerts. So because of the there was a lot of confusion. We used to get alerts for something like, you cannot ping Google. Why do I care about pinging Google? I don't care about it. So we just started to ignore those alerts. And when we started to ignore alerts, that became a big problem. When there were actually things failing, we would see some Nagios alerts, but we were like, maybe it's a false alarm. I don't know. I don't really care about it. So because of that, what we saw is that we basically ignored the alerts and things went wrong and we wouldn't even know about it unless someone complained. So that was really bad. So again, we decided to start from scratch. What we moved to was a much simpler solution, wherein we decided that we didn't really care about our application server monitoring that much in detail. We really cared about our application, whether the application was working, and if it had any problems. We wanted to know just about our application. So we put in a simple hosted services in. New Relic was there available at the time, which would provide extensive application layer monitoring. So we put that in, and what we saw is that we got good application layered monitoring. So whenever, let's say that I couldn't do a login, it would raise an alert. So that is something that we really cared about, that people can't log in. That's a big problem for Snap. So because of this simple yet elegant monitoring, we could get extensive application layer monitoring. But in addition to that, New Relic also provided us with basic server layer monitoring. So things like, is your disk full? You can set up alerts for that. So we started to get the right alerts that we were actually looking for. And even now, we just use New Relic. We don't have a lot of monitoring in, but we don't really need it. That's what we observed. The thing that Badri mentioned earlier is that whenever things used to go wrong, what we used to do is that we would try to SSH into the machine, and we had multiple components. So we used to SSH into 2-3 machines at a time, and everyone used to basically tail the logs and look at multiple machine logs, trying to figure out, okay, this is the problem. Now this application is talking to that other component, so I should look at that logs. So that was basically a lot of mess. And what we wanted to do is that we wanted to avoid logging or SSHing into the machines, and yet we wanted to see all the logs real time because the problems were happening right now. So what we did is that we moved to a application that would help us aggregate the logs and view them at real time. And one of that solution was Papertrail at the time. And we put Papertrail in. It was really simple to set up. Everything is fine. It is based out of syslog, and it basically gives you it gives you the logs of all your machines put together. And along that, on the same lines, it will also give you some basic searching and analysis. And you can even set up email alerts based on if you have any errors and something like that. So now we are in a much better situation in the sense that we have the right monitors and we get the right alerts. So if we get an alert now on Snap, we know that there is definitely something wrong. Another poor choice was that we were using Chef a lot right from the beginning. And we were quite familiar with Chef, and there was Chef server back then. So we decided to use that for Snap. So what we used to do is that people used to come and set up their pipelines on Snap, and those pipelines would run on build machines that were owned by Snap. So what we decided to do is that we decided to configure the users' machines as well using the same Chef server that we used to manage our own infrastructure. And that became quickly a problem because all the configuration for the users, it was tied to our application. So they would decide in their application whether they wanted to run with Ruby, whether they wanted some database. All those configurations were in the application. And that became configuration data in Chef. So we were basically abusing Chef server in a way to store users' configuration data as well. So that was a basic abuse of configuration management, and we were just using it the wrong way. And because of that, all our deployments were very coupled. Another thing that was problematic with Chef was that we would have all our chef cookbooks on the chef server. And whenever we did an upgrade and tried to run the user's build, it would pull down all the cookbooks, it would make network calls to chef server, and that basically slowed down the builds. And we couldn't provide any of this feedback to the users. So all they did was that they would see that, okay, a pipeline is created, but it would just be blank. So they didn't get any feedback, and it was really, really slow. So again, we decided amongst ourselves whether we really needed a chef server. What we found out is that we didn't really need a chef server because it wasn't really providing us any benefits. All we needed was that we needed to know what versions of cookbooks are deployed, and we could do that with just a simple Git repository, and we would check out the right version of the Git repository and run with Chef Solo. And so once we moved to Chef Solo, we knew that this version is right now running on production, so we know exactly what kind of cookbooks are running. And we also moved away. We basically had to remove all the configuration that the users' projects had into our system. So we actually became cognizant of the fact that what is actually configuration for our system. So in the future now, if we decide to move to Chef Server again, we know exactly what configuration should be going into the Chef Server and what is actually application data and not configuration. And another advantage was that with all of these services that we were moving to, we were basically removing one after the other services we had to manage. Like we removed our RabbitMQ, we removed Nagios, we removed Chef Server, so we didn't have to manage any of these services. This basically helped us reduce the cost as well as increase our deployment speeds and get more reliability of our deployments. So like Badri was saying that initially, whenever we used to do a deployment, we couldn't keep the system running. Now the reasons for those, like for that was that we just had one single mutable environment. So there was just one production environment, and we used to keep running Chef on that to upgrade the environments. And we just had too many components. We had 9 components back then. So it was very complex, it was very slow. And so we decided that no, this is not good. If we are providing continuous delivery to someone, they should be able to deploy at any point of time they want. We cannot go down. We basically wanted to move away from this downtimes to get to a state where we would have 0 downtime. So to move to that, we couldn't do a big bang change. We had to figure out a transition phase. So that was basically when the application would go into a read-only mode. So you could visit the website, you could see everything, but you couldn't run your builds, for example.
Or your builds would run, but we wouldn't accept any new builds.
Yes. So this was an okay place to be in because people could at least see their builds or see how their pipeline looked like. But it was still not good for Snap as a business because whenever you did a Git push on GitHub, we would never receive that because the entire application was only it was basically in a read-only mode. And if people used to try to log in or sign up for Snap at the same time, we wouldn't allow that because the database wouldn't accept any writes. So once we went to the read-only mode, we saw that we didn't really need many app components. We tried to reduce all the components. We tried to reduce our deployment times. And once we did that, we moved to a fewer components. We were able to move to a state that would allow us to do blue-green deployments. So let me just talk about a little that how blue-green deployments work for Snap. So we have a load balancer that basically accepts the network traffic. So whenever you go and type in Snap CI, it will go through the load balancer, and it will basically go to one of our web servers. So we had 2 stacks, 2 exactly similar stacks. We had the blue stack and the green stack. And right now, we would basically then route the traffic based on which stack was active. What we did is that the active stack would stay alive, and we would start the upgrade of the inactive stack. Once the upgrade was complete, we would just switch over to the new stack. Now, in order to do this, what we had to do is that we also had to move our database out, like the entire persistence layer. It couldn't stay in one of the stacks because we would basically tear down the entire stack and we wouldn't care. Like all of this were just build machines and a web server. So we had to basically move our database outside of our blue-green environments, and they would just talk to the database separately when they were active. So when we did this, what another thing we had to do different from any other Bluegreen was that we had to make sure that any users' builds that were running on the inactive stack after the switch, we had to make sure that we wait for those builds to complete, and only then we shut it down. So that was one thing that we had to take care of, and that we do even now. So if you do a switch, we have to wait, make sure that all builds complete, and only then we tear down the other stack. So this put us in a very good state. Now Snap can do deployments and the users are still not affected, and they still keep seeing the new features without any downtimes on Snap. Next, we'll have Badri talk a little about how we moved away from our coupled modules, or the number of modules we had. How did we reduce it?
So one of the things that you'll notice, we probably have to speed up just a little bit.
Yeah.
But one of the things that you notice is that we consistently moved from what might have been theoretically a superior solution technically to something that seemed a little bit of a regression, one step back. And we kind of had to do that in this case with the various components that we were working with as well. So I mentioned that we had multiple different components, but the interesting thing about how we created them was that it was never one of them that got modified. Anytime person changed component 1, typically components 2 and 3 would also get modified along with that. And that sort of coupling between components is exactly the thing you want to avoid when you're creating decoupled services-based architectures. And yet we had gotten ourselves into this bind because we hadn't paid attention to exactly what the criteria that should be used to create these components in the first place. We didn't know these criteria because we didn't have a working system. Because some of the criteria that you use to carve out components are typically things like rates of change, which parts of the application change with what rates, data ownership, who owns which part of the data and gets canonical representation to authority to represent that data. Those were the things that are really important. So we started out in a highly coupled initial state because we didn't have the information to create the decoupled elements, but we still had them, so we had all the complexity. So what we then did was we chose to move back to a monolith. We said, you know what, all this coupling, we've got all the problems of a monolith, and to make things worse, the monolith is not even in one repository. We've created a monolith that's split across multiple repositories, so it's the worst of all possible worlds. So we decided that we were going to cut our losses and move the coupled system into one repository. At least that way you can see all the code that is currently being affected. So once we moved things into a monolith, we had fewer moving components to deploy, which meant we were able to deploy more frequently along with all these changes. So now we were in a place where, yes, we still had all that coupling, it was nasty, but at least we had something which we could deploy. And when we can start deploying more frequently, you can start iterating more frequently, which means changes happen more frequently. You now get to see how data flows through your system. You get to see which parts of your system change with each other, so you understand the coupling and cohesion characteristics of your system, and that lets you create real modules. So now we were able to see what modules needed to be created, and now we're back onto a system that actually has modules, but for now, these modules are actually decoupled. If we want to make a change to how artifacts are persisted and propagated across Snap, there's exactly one module that changes. If we want to change how your build runs and the environment in which your build runs, there's exactly one module. And if we want to change the UI, there's one module for that. And these were the kinds of things that used to be coupled crazily before, and now we've been able to move past this by taking this one step back and then one step further approach that we did for all of these things.
So in a sense, we could figure out what are our application boundaries and what could be the right components for Snap.
Right.
When we moved to a monolith, actually.
Right, exactly. So in the current state, most build setups at this point actually pass. Most users can log into the system, create a build that always runs. And if there are failures, the team immediately gets notified. There's no more hunting around to see if a user's build failed. Deployments happen every other day. We release much less frequently because we tend to package up our features into slightly meatier chunks for our users to be able to use them in larger groups. But we release almost every other day, multiple times a week. And we have near zero downtime despite running extremely long-running processes. Every build is a long-running process. And despite that, we have near zero downtime in what we do. So this is the brave new world that we find ourselves in. Of course, not everything is perfect. I'd be lying to you if I said that everything today is completely perfect and there's nothing we would change. In fact, if we had to do this talk a year from now, I'll probably come and completely crap all over the state the system is in right now and tell you about how we made it better in a year's time. But I think that's kind of the part of the deal. The key is to focus on the things that you are not doing well right now and set into motion a process of improvement through which you can actually improve things and not be afraid of being critical about yourself. Because at the end of the day, we all work together on a team. Our goals are the same. So given that our goals are the same, it's pretty easy for us to do the right thing by our users. So what is our current working style? There are some essential elements to our current working style that I'd like to talk about. First is an appropriate sequencing of stories. We've got a lot more rigorous about this. We'll get into details about each of these in a second. Using feature toggles extensively. Structured evolution of the data and the application, and using identical environments as tripwires. So what do we mean by these things? So sequencing of stories. Any significant piece of functionality is typically going to end up being multiple developer stories. In the product manager's mind or in the customer's mind, they may represent one feature, but in the developer world, it's rarely ever something that gets built as one large chunk. Well, or you could do it, but then you run into this problem where you could take the entire set of all that needs to be done, make one giant change, and try to push it through your pipeline. And yes, that might be the smallest amount of work you can do, but it results in a much higher risk because now you've got this giant change that's flowing through your pipeline. It becomes an all or nothing deployment, and we hate all or nothing big bang deployments because when things go wrong, it's hard to find out where things went wrong because you're pushing a pretty large piece of work through. Everybody talks about breaking things down into smaller pieces, but the consequence of breaking things down into smaller pieces is that work gets done over a much longer period of time. That causes its own set of problems. So the interesting thing about continuous delivery is that it's a pattern language. Every pattern has a context in which you apply it, and patterns create problems of their own. So splitting work out into smaller pieces makes that work happen over a longer period of time. It minimizes the amount of delivery risk, the technical risk, but first off, you're doing it over a longer period of time. Competitors may do an end run around you, and more importantly, you may end up doing more work. And we have agreed that it's okay if we end up having to do a little bit more work in order to finish a story. It's much more important for us to be able to release every piece of it every day if we wanted to. So it's a question of us setting priorities, and in this way, we use this principle of spreading the work out over a period of time to create less technical risk and make it possible for us to deliver more frequently.
So the advantage that we got is that we were able to reduce the risks by doing more work, but we didn't have the tension when doing the deploys. We knew that it's a small change, and we know that it would work with the existing system that we had.
Right. And feature toggles.
So next I'll talk a little about feature toggles. We use feature toggles extensively on Snap. Whenever we are doing any new big feature, we will use feature toggles. Like one of the big things that we did recently on Snap was introducing test parallelization. So people could go and set up one stage, and it would spawn up multiple machines and run their tests on multiple machines in parallel. And that would basically give faster feedback to our users. Now, this was a massive story, and it basically had to be sliced down into smaller stories. And we would keep on releasing new things into our system, but we had to make sure that the entire thing was kept hidden from our users. But all the changes, all the backend changes were being made, and if we wanted, we could switch over, and we would know for a fact that things actually do work. So the way we did it is using these feature toggles. So it was simple, like feature toggles, it was just adding some conditionals that would basically show or hide some HTML based on what the value of that feature toggle was. So we were basically hiding some UI elements using these feature toggles, but at the same time, we were using the same feature toggle value to basically decide what the application would do in the backend. So we were using the feature toggle value also to test our features. So we were putting new code out with conditionals, and we were also testing these toggles and the functionality. So we would basically have more tests. We would have tests for the feature enabled, as well as we had to keep our existing system running with the feature disabled. So we were in a state, we would be in a state where we would be writing more tests. And we would be running the tests for both the feature enabled and the disabled cases. And what we tried to do is we also tried to avoid multi-component feature toggles because it's basically very complex to manage. So what we tried to do is that whenever we have components, we basically, if we want to invoke a new sort of change, we would basically never look at the new interface if we didn't really need to use it based on the feature toggle value. And based on that, we were able to get away with deploying a new feature without having to use multi-component feature toggles of sorts. So how did this actually work? So like I mentioned, we were working on this new test parallelization thing, and this is a sample code. Like we were using ERBs, so we were able to write some Ruby code in our HTML templates. And what we did is that we would generate some HTML if the toggle was enabled, and we would generate some other code, the older HTML, if the feature toggle was disabled. So this is like a simple if-else condition for the HTML. Similarly, in the backend also we did the same. If the feature toggle is enabled, you would invoke this new logic that would run your tests in parallel. Otherwise, you would just continue with the old logic that was there. For the tests, it's the same. You would test for both with the features enabled as well as the features disabled. So like Badri was mentioning, that this is more work, but this gave us the guarantees that things, if they were broken, we could always go back to the old system.
And when we get to the next bit where we talk about using multiple environments, you'll realize the value of keeping both sets of tests running. This proved really important for us, keeping both the old behavior and the new behavior running and having assertions against both states was important because we had different environments with with the features turned on and off. So we needed to be able to assert the behavior of both systems, and we needed to be able to say, is the feature broken in environment 1 and is the old feature broken in environment 2? So we needed to have both sets of functionalities working, both the old way and in the new way.
Yeah, exactly. So next, we had to look at the migration of our data as well. When you are doing a big bang change, you know that, okay, I'll be creating tables, this, that. Okay, I'm done. But if you are talking about small incremental changes, you have to also consider your data. And what we had to do is that we had to basically consider this was a system that was running throughout. Whenever we were developing any new features, there was already something running in production. So we had to consider the existing data as well as the existing schema. So taking that into consideration, what we had to do is that we had to make small incremental changes that would make sure, or that would at least help us release small changes, but at the same time make sure that things wouldn't break with the existing data. We also had to consider rollbacks, because if things go wrong, you want to go back to the old system and it should work fine. And this became doubly complex when you had to do zero downtime deployments. So to go back to our example of how did we do this test parallelization thing, the thing is that Snap runs all the users' tasks or commands, their builds, in a stage. And we basically had to introduce a new model called jobs. So we introduced a new table in our database called jobs. It was simple, it didn't have any data in it right away, but it just created a new table in our schema. Next, what we did is that now we had this table in production. We basically had to make sure that we had to associate every stage with multiple jobs, because eventually every stage would basically spawn into jobs and it would run on these jobs. It would basically, so what we did here is that we associated every stage with a job. Now, once we knew that every stage had a job, we could basically make sure that we could copy any existing attributes over from the stage to the jobs. So in this state, Snap would basically, whenever it used to create a new stage, it would also create a new job for it, and it would write attributes, the attributes that are needed for jobs, it would also keep writing to those stages. So we were doing double writes to both the tables, but it was okay, it was in transition. Now, how did the application really work? Like, this was like before we worked, before we started.
Did you have a question? Oh, sorry. Okay.
So before we started working on our multiple test parallelization and jobs work, we would have, this is an example where we were just basically trying to compute the result of the stage, whether a stage has passed, failed, it has been cancelled by the user, etc. So we would just read that field from the database. Now, when we decided to move to multiple jobs or multiple test parallelization, a stage would either pass or fail based on any of its jobs had failed or all of its jobs had passed. So now this, again, we had to include the feature toggle, and we had to compute this thing. And otherwise, if we weren't using multiple jobs, we would just look at the database field again. So this was in the transition phase where we were using feature toggles. And once we knew that everything was working, we would basically move back and we would start using this new feature wherein we used to compute the stage result based on the result of the jobs. So this is how our code transitioned, and when we knew for a fact that everything was working, only then we got rid of the double writes and we got rid of the attributes that were no longer needed on the stage, and we were basically just started to use the jobs to run all our tests. So this is how we basically did the entire change incrementally and small change at a time. Now Badri will talk about how we basically use Snap to build Snap in a way.
Right. So this is the really key part as to why we had to keep both features, both the feature enabled and disabled, and the test for both of them running at any given point in time. The way Snap works is that our gateway to production is our staging instance. So all our customers use, we have about 3,000 users right now. They all use the production instance. The Snap team ourselves, we use a staging instance which has a gate that actually promotes things to production. So we are gated with our own deployments through our staging environment. So let's say the staging environment is at version n and it's building version n+1. I've given a much more simplified version of what our deployment pipeline for staging looks like. But roughly, we build and test version n+1. We then upgrade staging. So staging upgrades itself. Remember, because we can do blue-green right now, it's actually possible for an environment to upgrade itself. It actually activates the other stack and then switches traffic over to it, and it actually works. So staging upgrades itself. So staging moves to the next level, and then we run a bunch of smoke tests on it to see if it's actually working as expected. So the way this works is, so we build version n+1, staging gets upgraded. So now staging is at version n+1. It has finished upgrading itself, and we are ready to run our smoke tests. Let's say they fail. If they fail at this point, so you can see that the promotion to production cannot happen at this point. So effectively, staging has ended up becoming a fuse, if you will, to prevent any bad build from getting through into production. At this point, the team will need to create a fix for the thing that broke in staging. That starts building version n+2. At this point, if that build passes, the upgrade would then upgrade staging to version n+2. And that would then run our smoke test. And if the smoke test passed at this point with that fix in, that then gets promoted to production. So with this mechanism, what we have is our staging runs a version or two ahead of production and effectively acts as a gatekeeper to preventing bad builds from ever getting through to our users. Because we in a sense are users of Snap ourselves. So if we've botched something up, we make sure that we are the people who are impacted first and our users are not impacted. And once we know that we are the ones who are impacted, this then starts affecting our ability to release and deploy. So we have an incentive to actually fix it. It so turns out that if it is a poor user who doesn't complain for a very long time, you don't realize that you're not able to upgrade production. But if it's you yourself who can't do a deployment, the team feels a little bit more pressure. So this was one way we were able to put pressure on ourselves to fix the problem and make sure that only good builds ever got through into production. So these were the mechanisms, these are the kind of mechanisms that we have in place to actually make development be a little bit more rigorous and work the way we want to these days for us. So in summary, the kind of, this is basically a recapitulation of what we've just looked at, but it gives a state of what the team thinks like and how we work and the things we prioritize today. We start with the assumption that our primary goal is to get good quality working software into the hands of our users as soon as possible. That's our axiom. That's not what comes out at the end of a long process or technical challenges. That is our primary goal. That is goal 0. We layer on qualities such as reliability, automation, frequent releases, etc. on top of that. We can do that in different levels. Different parts of the system may acquire different levels of these characteristics at different points in time. But that's much better because now we get to choose and do the right kind of trade-offs, which is what doing architecture and design is all about, to know which parts of the system need which of these qualities at what points in time. We are actually very happy to kick the can down the road. So if a user has a big problem and we know that the absolute right way to fix a problem is to do a gigantic feature, we look at what is the smallest possible feature that we can build that will solve that user's problem, just so that we can kick the can down the road, because doing a smaller feature will allow us to release it, and it might fix the problems of a whole group of people, maybe not everybody who has this category of problem, but a significant number of them. And it's much better to be able to do something good today rather than do something perfect, which is going to take a lot longer and not get into the hands of users soon enough. We're not afraid of redesign or rework. There is no concept of rework. We've redesigned for example, we had a pipeline. The pipeline concept worked. Stages worked, but we had to redesign how it worked when it came to jobs. We don't look at it as redesign. As long as we are still delivering valuable functionality to users, it doesn't matter that what we're doing might be a re-implementation of something that we already had a month ago. And finally, with all these things in place, we let continuous delivery be the thing that guides our architecture and design rather than the other way around, rather than saying we're going to pick an architecture and a design that is somehow going to magically manifest itself in continuous delivery. So by refocusing our attention on what we want to achieve and then realigning our design and architecture and the tool choices to actually make that happen, we've found a much better way to implement this process for ourselves, and in the process also build a reasonably viable business at this point. And that's it we had. Time for questions at this point. Yep.
You're doing blue-green deployment.
Yeah.
How far down the stack do you do that?
Can you be a little bit more specific about what you mean by that?
Just in production and staging, or are you doing it?
Oh no, every single environment. All environments get our blue-green deployments. The good thing about something like Amazon is that you don't really have to pay for infrastructure that you're not using, so you don't keep a second copy of the hardware lying around. So you get to bring it up just when you need it, and that's what we do.
So the advantages of doing that is that we exercise the blue-green scripts all the time. And what we usually do is that we don't have a massive staging environment. We have a really small staging environment, so we don't have to pay the cost.
The other thing you'll notice is that we could not possibly have staging upgrade itself if we weren't doing blue-green, because if staging were to go down in the middle of upgrading itself, that's it, the build would die midway.
Yeah.
So we have to have blue-green running in staging for staging to be able to upgrade itself. And that process of bootstrapping, although we got to that point with a lot of difficulty, that is key in our being able to reliably do deployments today. Yep.
Your picture of the way you did blue-green deployment and the way you had the database separated out,
Yep.
Is that something that has been published or written up? Is there a way we can find out more about the mechanics of that?
I do not know if it has been written up. So if I were to tell you that it has been or it hasn't been, that would be a lie. But I think what we've realized is that if you really want to do blue-green, the first thing that you want to try and do is make your application state, any application state, be externalized as much as possible, so that what constitutes your application and the part that's going to be brought up is essentially stateless and does not need any prior state information to be brought up alive.
What I'm interested in the write-up is we've gone through those kind of discussions, but you inevitably get to what happens when we need to update the database.
Right.
Yes.
And in fact, the topic of database migrations is a fairly complex one that we could have gotten into, but that would have been a talk in and of itself. Yeah, so we have automated database migration scripts that run with every deployment. And the process that Akshay mentioned of making incremental changes, adding the jobs table, then associating each stage with a job, and then slowly adding data, and then adding the structure to the jobs table, and then copying data over to it. All of that happened over the course of 2 to 3 weeks.
Right.
So it was one migration after the other, each of which ran in every single environment with data over a period of time, with the caveat that this feature was always turned on in staging. So we were using this feature. So we were using data that was in a mixed mode, so was working with just single stage mechanisms and with this parallelization turned on. So we were doing these deployments and migrating this data, so we knew that these database scripts would work when they ran on production.
Yeah.
So now that we know that they run in production, we are not worried as much about having an automated database deployment process because it's been proven to run, it's been proven to work with production-like data because our staging environment contains production data for the Snap team itself. And so then that becomes the thing that we run in production, and that automates the entire deployment process over there.
Can I try and play that back in a sentence or two to make sure I've really understood?
Sure.
The reason you don't need to do blue-green deployments on databases is because you have really well-tested migration scripts, which means that you can continually, gradually update the data in the database.
Yes.
You have to make sure the database is compatible with one version behind the one you're going to deploy.
Yes.
Yeah. That's clear, yeah.
So in addition to that, we also need to consider about the rollbacks. So in case something does go wrong, we need to make sure that we can roll back the entire change. So we do think about if there is a destructive operation, like the last step was basically removing the columns. So you do need to make sure that you are not really using those columns and your application has used the new table. So you do need to make sure that everything is working with the new data. So destructive operations, you need to take care of them. So you need to make sure that the rollbacks will work.
Fantastic, thank you very much.
Can I ask an honest follow-up question? Like, how much do your developers like that? How well do your developers cope with the mental sort of burden of having to maintain the two models and schemas in mind? Do you have good tooling around it to make it easier? Like, this is a clutch problem that I have in this environment.
So
I found that there's lots of good tools for modifying database schemas, but not so good for being additive only and supporting multiple versions of the application. So how is it really working?
the tests that we showed with the feature toggles enabled and the feature toggles disabled make it necessary for us to make the application work with both. So how much do the developers like it? Well, you've got to answer that. I can't answer that for you.
Yeah. So what we have seen is that when we started with feature toggles, it was a little painful because you know what, we had to do more work. So it seemed like, why are we doing this? Is this really bringing any value? But when we started to put this out into production, and when we saw that we could actually run our staging with a newer version with the feature toggle enabled version, but the production was still running with the old one, even though the code was already there, it gave us much more confidence to go ahead and make the changes. And we were able to do rapid development with the feature toggle enabled, but the feature toggle disabled, everything was just working fine. So that actually enabled us to deploy faster and develop faster rather.
So the one thing that they did not ever have to do after that point is stay back on a Friday night wondering why this deployment got screwed up, and they could actually go out for a beer. They could actually do a deployment, push things out into production, know that nobody was going to be impacted by it, and go out for a beer like normal civilized people do on a Friday evening.
Yeah.
Rather than working at 9:30, and I do realize that this talk is probably the one thing that's keeping everybody here from beer as well, but no, so yes, there is the overhead of people having to keep track of this while doing development, but then that pays off in other ways in that it reduces the stress of actually doing releases and deployments.
Yeah.
And the important thing to keep in mind over here is that we don't have a separate ops team. Like, this is dev, this is ops, this is DB migration, this is everything. Well, him and 3 others that look a lot like him.
And we have one Badri.
And there's one of me.
That's everything else. Yeah.
So what this means is that there is no problem that we're offloading to somebody else. So in other words, the benefits of doing this is actually a material benefit for this group of people directly. And that is the benefit that you get when you put your dev, and this doesn't have to be just the dev team. It could be the devs, the QAs, the ops people, and the designers all working with each other in the same team means that the team that makes the change gets to reap the benefits of the change as well. So you're not waiting to do this and the dev team takes all the mental burden and it's an ops team that seems to get the benefits. When you two work together, it's the same team that gets the benefit of doing all this work. So we harvest that benefit in other places.
Yeah.
You had a question, Chris?
It changes tack though. I'm interested on how you handled the loss fallacy at the beginning of your story. The ability to drop what you'd invested so much time in. And that's something a lot of people probably struggle with, or teams.
Did you mean where we work?
Major changes that we did?
Yeah.
Oh, right.
Yeah.
Dropping everything you'd invested.
Oh,
Yeah.
right. Oh.
Yeah, that's always hard.
That was really hard.
Well,
how many weeks did I have to convince you guys
Yeah.
to do that?
So we had built a lot of things. We had automated so many things, and what the deal was that it was a little difficult, but we could see that people are actually not benefiting from it.
Yeah.
Like we were using Snap in the early days, and we would struggle with it. Like if I couldn't, So if I couldn't set up my pipeline, how can I expect anyone else to set up a pipeline?
I did one sneaky thing. I tried telling the team that this would just never work. And then I did one sneaky thing, which was I did an entire round of usability studies with the app in the old state as it was, and I recorded users as they were working through a very simple script which said, connect your GitHub repository, set up the world's simplest build pipeline, which is just one stage that just ran rake or ant or whatever it was. Nobody could complete it. People were confused. People didn't know why the app wasn't working. They were not getting any feedback. And the frustration on users' faces was reflected in the video that we recorded, showing them trying to accomplish this most basic of tasks. And you take that to your development team, no matter how much they feel the investment in what they've done, there aren't very many truly good development teams that will not see that sort of frustration on a user's face and say, oh my God, we've screwed up really badly. So you take that to them. I did not have to do any further convincing after that point. I mean, everything else, they were just like, this has got to happen because we cannot inconvenience our users. And it really and I think that's the part which is past the development. So there's understanding stories and sequencing. There is the technical work that you do. There is the user experience and design work. And then there is the feedback loop that comes in after that. That part is critical to being able to complete this cycle and making the development teams understand what the users are actually going through. So doing usability testing and showing the consequences of actually making these changes is actually really, really important. And that was the thing that changed the team's behavior in this case.
Cool.
All right.
Okay.
Thank you.